Hi guys, and welcome to Miss Anderson's class. Today we will be learning Chapter 5.1, Mental Computations, and I will be teaching you mental computations of whole numbers. But first, let's get some background information. When people hear the word computation, they usually think of paper and pencil computations using the methods they learned in school, but computations can take many forms. At sometimes one might wish to compute mentally simply because it's more convenient than finding a pencil and paper or a calculator. To become skilled at mental computations, it takes some practice, which we will be doing today. One important advantage of practicing mental computations for children and for adults is that it helps to develop flexibility of the use of numbers, and properties of operations gives them a sense of control over their numbers. So our first example here today is 147 minus 66. Not too friendly numbers. So here's what we're going to do. We're going to add something to each side. Let's take the number 4 for example. 147 plus 4 equals 151. 66 plus 4 equals 70, a nice rounded number. We're going to subtract these two. 70 is a little bit of a big number to be taken away from 151, so we're going to break it down into 50 minus 20, because we know that 50 plus 20 equals 70. So we're going to take 151 minus 50, and we know that 150 minus 50 is equal to 100. And then we're just going to add our 1 down to that guy right there, making him 101. Now, I have to take the 101 and subtract 20 from it, because this is the only other one that we haven't used yet. So I'm going to go 101 minus 20. Now, that looks a little funny, so we're going to make this 100 for now, and keep our 1 over to the side and use it later. So we know that 100 minus 20 is 80. Then what do? We add our 1, and the answer is 81. Alright guys, there's our first example complete. And now we're going to work on example 2, which is 1000 minus 729. Now here, we can look at 1000 and we can see that that is a perfectly rounded number. But then when we look at 729, that one's not as friendly. It's an odd number and the numbers are just a little funky there. So what we're going to do is we're going to keep our 1000 and we're going to make this one into a little bit of a nicer number. So I'm just going to take 700 for example. I'm going to do 1000 minus 700, reserving our 29 over to the side. Now this may seem a little big to you as well, and if this looks intimidating, we can also make this more simple. Let's just cover up the two columns of the zeros for a second. So now all we have here is 10 minus 7, which we know to be 3. And then we just bring down our zeros. So 1000 minus 700 equals 300. But what about our 29? We still have that left over. We could go 300 minus 29, but since 29 is not too friendly, we're going to break that down as well. We're going to go 300 minus 20, reserving our 9 over to the side. 300 minus 20 is 280. We still have our 9 over to the side. If this number still isn't too friendly for you, we could break this down as well. Let's take 5 for example. We'll go 280 minus 5, which is 275. We took 5 away from this guy. We have 4 left to play with. 275 minus 4 is 271, and there's our answer for that one. Now, I'm going to talk about a common misconception when doing mental computations. At many times, the case of mental computation depends on the numbers used and the familiarity with the properties of operations. The computation should not begin before looking over the numbers and thinking of different ways to reorganize or rewriting the numbers. So we're going to consider the following number here. We have 38.6, ignore that, let's go, 38.6 plus 27.2 plus 4.8 minus 38.6. Wow, that's a lot of numbers, right? And look at all the decimals we have this time. That is a lot. So what we're going to do here to make this a lot easier on ourselves is we're going to look for common numbers here. We have 38.6 here, and we have another 38.6 down here with a negative in front of it. We're going to take these two guys and they're going to cancel each other out, leaving us with 0. And then we have 27.2 plus 4.8. Let's add these guys up right here to make it a little easier. And then we know, we're just going to leave this row alone for a second. We have 27 plus 4, which equals 31. And then we're going to take these guys and we're going to separate them and put them all the way over here and play with them. We know that 8 plus 2 is 10. So we're going to follow our decimals. We're going to bring this guy up and drop him down. This is 1. So 31 plus 1 equals 32. And remember that the common misconception here is that sometimes students or even adults get too excited when they see big numbers like this and immediately start to try to add them up in their heads, which can be very confusing. It is possible, but it is confusing. So before you start to get frustrated and start to add these big numbers up in your head, or try to look for something common, like our 38 plus 6.6 and 38.6, which we're able to cancel out and make this easier for us. Thank you guys, that's the end of our lesson. I hope you enjoyed it.